A pleasant day to each and everyone.
I am Jada.
And I am Argile.
And I am Rainkind.
I am Charlie May.
And I am Lendel. And I am Karen.
And we are the Amines Group.
Learning objectives. At the end of this chapter, students will able to recognize the name and amines, recognize the basic structure, physical, and chemical properties of amine, know the different methods for preparation of amine, and lastly, the chemical reaction. Amines. Amines are compounds that derive from ammonia by replacement of 1, 2, or 3 hydrogen by alkyl or aryl groups. Aryl group is any functional group or substituent derived from an aromatic ring, usually an aromatic hydrocarbon, such as phenyl and naphtha. These are the structure of ammonia, and this is the termethylamine. Nitrogen atom with a lone pair of electrons, making amines both basic and nucleophilic. Amines occur naturally in plants and animals. The relation between ammonia and animals. These are illustrated by following structures. Is it ammonia, primary amine, secondary, and tertiary. Amines are classified as primary, secondary, or tertiary, depending on whether 1 or 2 or 3 organic groups are attached to the nitrogen. Aliphatic amines contains only alkyl groups bonded directly to the nitrogen atom. These are the structure of aliphatic amines. Aromatic amines are those in which 1 or more aryl groups are bonded directly to the nitrogen. Mauni ang structure sa aromatic amine.
Now let's proceed to the common name example of amine. So number 1 example is nitrogen, and we have hydrogen and 2 methyl attached. So duha man ni siya ka methyl mo nang we need to use the word di. Mo nang dimethyl. And then mag-add ta og word nga amine. Mo nang ang common name example sa number 1 is dimethylamine. So next example number 2. Nitrogen, and we have 2 ethyl and 1 methyl attached. So duha man si ka ethyl mo nang magamit pud tag word nga di, mo nang diethyl, and then methyl, and then mag-add pud ta nga word og amine mo nang diethyl methylamine. Okay, last example, nitrogen, and we have methyl, ethyl, and propyl. So we will put it in alphabetical order. Since E comes before M and M comes before P, so ethyl, methyl, propyl. And we need to add the word amine. So the common name of the example number 3 is ethyl, methyl, propyl amine.
And now, let's proceed to the ayupak example of amine. Example number 1, we have amine and metal. So, in naming the longest chain, we should prioritize the amine. So, we will label it into 1, 2, 3, 4, 5, 6. And since 6 is hexane, we should eliminate E and add amine. So, we have hexanamine. Then, we should name it into 2 hexanamine, then add the 5 metal. So, we will put it into alphabetical order. So, 5 metal and 2 hexanamine. With example number 2, we have amine and 1, 2, 3 longest chain. And since it is 3, we have propane, and we should eliminate E and add amine. So, propanamine. And since 1 is belong to amine, we should name it into 1 propanamine. Example number 3, we have amine and 1, 2, 3, 4, 5, 6 longest chain. So we will have it into hexane, and since it is cyclo, we will add it into cyclohexylamine and add the amine, which would result cyclohexylamine. Example number 4, we have amine and we have 6 longest chain. And since amine bonded to metal, we will name it into N-metal. And since 3 amine is bonded into third carbon, that's why we have 3. And then since it is 6 longest chain hexane, then we should eliminate E and add amine, which will result into N-metal 3-hexanamine.
Physical properties of amine solubility in water. All 3 classes of amines can form hydrogen bonds with the oxygen to hydrogen group of water that is oxygen to hydrogen. Primary and secondary amines can also form hydrogen bonds with the oxygen atom and water. Nitrogen to hydrogen. Amines with up to 6 carbons show appreciable solubility in water. The unshared pair of electrons on the nitrogen atom dominates the chemistry of amines. Because of these electron pairs, amines are both basic and nucleophilic. Of aqueous solution of amines are basic because of the following equilibrium. A ammonium ion hydroxide ion, the most convenient way to measure the basicity of an amine RnH2 is to look at the acidity of the corresponding ammonium ion. RnH3 plus RnH3 oxygen hydrogen Eb equals to RnH2 PKb equals to dash log Eb.
Methylamine and ethylamine are gases, but primary amines with 3 or more carbons are liquids. Primary amines boil will have alkanes with comparable molecular weights, but below comparable alcohols. Intermolecular nitrogen-hydrogen bonds are important and raise the boiling points of primary and secondary amines, but are not as strong the oxygen and hydrogen bonds of alcohols. The reason for this is that nitrogen is not electronegative as oxygen is. Alkane CH3, CH2, and 30 BP-88.6 degrees Celsius, and 6 CH3 and CH2 and CH3 44 BP-42.1 degrees Celsius. And the amine CH3 and NH2 31 BP-6.3 degrees Celsius, and CH3 and CH2 NH2 and 45 BP negative 16.6 degrees Celsius, and the alcohol CH2 and OH3 32 BP positive 65.0 degrees Celsius, and CH2 and CH3 OH 46 BP negative positive at 75.5 degrees Celsius. Tertiary amines are also polar compounds, but because hydrogen is not bounded to nitrogen, these amines are incapable of intermolecular hydrogen bonding. Their boiling points are lower than primary and secondary amines, of identical molecular weights, and higher than those of alkanes of similar molecular weight.
Today, I will explain the reactions of amines. Amines are chemicals that contain nitrogen. They can react with other substances in different ways. These reactions helps us create useful products like medicines, dyes, and cleaning agents. So here are the different types of, or the main reactions of amines. First, we have reactions with acids, salt formation. Amines react with strong acids to form alkyl ammonium salts. Second is acylation of amines, amides formation. Primary and secondary amines react with acid halides to form amines. And third, imines formation. Primary amines RNH2 or ARNH2 undergo nucleophilic addition with aldehydes or ketones in an acidic buffer to give substituted amine. Fourth, aromatic diazonium salts. Primary aromatic amines react with nitrous acid at 0 degrees Celsius to yield aryl diazonium ions. The process is called diazotization. And fifth, aromatic diazonium salts. They are useful in synthesis because the diazonium group can be replaced by nucleophiles and the other product is nitrogen gas. And the last part, we have uses of amines. First, amines are largely used in pharmaceutical industry. Many of the medicines we use contain amine groups because they are biologically active. Second, morphine and demerol are used as analgesics that are painkillers. Some well-known painkillers like morphine and demerol are amine-based. These drugs act as analgesics, which means they help reduce or eliminate pain. Third, we have Novocaine is used as anesthetic and ephedra is a very common decongestant. Amines are used in anesthetics and decongestants. For example, Novocaine is an anesthetic used to numb pain during surgeries, or as we all know, as anesthesia. And ephedra is a very common decongestant used in treating cold symptoms. Fourth, we use tetramethyl ammonium iodide for disinfecting drinking water. Tetramethyl ammonium iodide, which contains amines for disinfecting drinking water. It helps make water safer to consume. And lastly, they find large applications in man-made dyes. Amines play a big role in the dye industry. Many man-made dyes that are used in textiles and other materials are made using amines. Amines are extremely useful in medicine, healthcare, sanitation, and industry. Their role in improving our daily life is really significant. Thank you.